Right. So we are in the topic probability distributions, right? We are in the topic probability distributions. So far, what we have discussed was what? How to identify a probability distribution, then how to calculate mean, variance, and standard deviation for a given probability distribution. And then we have discussed that there are two types of probability distributions. Hope you can remember. One is discrete probability distributions. The other type is continuous probability distribution. So far we are in the discrete probability. So far we are discussing about discrete probability distribution types. One type we have already discussed, that is what? Binomial probability distributions. So today we will basically discuss what? Poisson probability distributions, right? Before coming to this Poisson probability distributions, can you remember how we have identified a binomial probability distribution? අපි කොහොමද binomial probability distribution එකක් අඳුනගත්තේ? Basically there were two things. What? මතකද? One is the experiment should be repeatable. දෙවතාවක් හෝ ඊට වඩා වැඩි වාර සංඛ්‍යාවක් කරන්න පුළුවන් වෙන experiment එකක් වෙන්න ඕන. What was the other thing? In a single trial, there should be only two possible outcomes. එක trial එකක් විතරක් consider කරොතින් එතන තියෙන්න පුළුවන් outcomes දෙකක් විතරයි. If it is such, we have identified those probability distributions as binomial probability distributions, right? Then how can we identify this one? Poisson probability distribution, right? What it says? Poisson probability distribution here. What is a discrete probability distribution? When it says discrete, you know what it means, right? Discrete අනිත් වචනේ මොකද්ද? Continuous. Discrete නම් possible outcomes වෙන්න පුළුවන් මොකද්ද? Only some specific values. In other terms, there cannot be decimals. Decimals තියෙන විදිහ නැහැ, right? It's a discrete probability distribution. And the second point is what? Used in situations where events occur at random points in time or space. කාලය හා අවකාශය සම්බන්ධ තැන්වලදී අපිට සම්භාවිතාවය කැල් කරගන්න ඕන වුණොතින් in those situations we are going to use this Poisson probability distributions, right? If we want to calculate the probability with related to time or space, කාලය හා අවකාශය සම්බන්ධ තැන්වලදී අපිට සම්භාවිතාවය කැල් කරන්න ඕන වුණොතින් අපිට සම්භාවිතා අගයන් දැනගන්න ඕන වුණොතින් in those situations we are supposed to use Poisson probability distributions, right? For an example, right? For an example, on an average, there are 10 COVID-19 patients reported per day in Sri Lanka, right? සාමාන්‍යයෙන් දවසකට ශ්‍රී ලංකාවේ COVID-19 patients ලා 10 දෙනෙක් report වෙනවා. If that is the case, what is the probability of reporting 20 patients per day? Right? ඔය වගේ. නැත්නම් සාමාන්‍යයෙන් patients ලා 10 දෙනෙක් report වෙනවා. එහෙනම් patients ලා 20 දෙනෙක් report වෙන්න තියෙන සම්භාවිතාවය කීයද? සාමාන්‍යයෙන් patients ලා 10 දෙනෙක් report වෙනවා. patients ලා 5 දෙනෙක් report වෙන්න තියෙන සම්භාවිතාවය කීයද? 6 දෙනෙක් report වෙන්න තියෙන සම්භාවිතාවය කීයද? එක patients කෙනෙක්වත් report නොවී තියෙන්න පුළුවන් සම්භාවිතාවය කීයද? If we want to calculate probabilities as such, then we can use what? Poisson probability distributions, right? Just an example, right? Right? Here, several examples have been given. Random occurrence in time. කාලය හා සම්බන්ධ දේවල් වලදී, for an example, arrival of customers at a service station. Service station එකට සාමාන්‍යයෙන් customers ලා 100ක් එනවා. ඒක අපිට කැමති කාලයක්. එක්ක දවසකට නැත්නම් සතියකට නැත්නම් මාසයකට නැත්නම් අවුරුද්දකට. If we take per week, if there are on an average 100 customers, what is the probability of arriving 200 customers per week? සාමාන්‍යයෙන් සතියකට 100ක් එනවනම් 200 එන්න තියෙන සම්භාවිතාවය කීයද? 101ක් එන්න තියෙන සම්භාවිතාවය කීයද? Right? That sort of a thing we are going to do here. අපිට average එකක් දෙනවා. ඒක base කරගෙන අපිට දෙන ඕනෑම අගයකට අදාළ probability එක කැල් කරන්නයි මෙතනදී තියෙන්නේ. Random occurrence in a space. Random occurrence in a space. Right. Here, what it says, number of printing errors in each page of a book. Right? පොතක් ගත්තොත් සාමාන්‍යයෙන් එක පිටුවක printing mistakes 4ක් තියෙනවා. එහෙනම් printing mistakes 6ක් තියෙන පුළුවන් සම්භාවිතාවය කීයද? If we want to calculate those things, we can make the use of Poisson probability distributions, right? Several other examples also being given right here. Number of telephone calls arriving in a given interval of time, right? අපි ගත්තොත් පැයක් ඇතුළත මට කෝල් සාමාන්‍යයෙන් 4ක් එනවා. එහෙනම් මට දැනගන්න ඕන මට පැයක් ඇතුළත කෝල් 8ක් එන්න පුළුවන් සම්භාවිතාවය කීයද? මට පැයක් ඇතුළත කෝල්ස් 4ක් සාමාන්‍යයෙන් එනවනම් මට කෝල් 10ක් එන්න තියෙන සම්භාවිතාවය කීයද? In those situations, right? Number of automobile accidents occurring at a certain junction on each day, right? Number of suicides reported in certain city every year, right? Number of defects in each 100 square meter floor area on a tiled floor, right? All these things are related with time and space. කාලය හා අවකාශය සම්බන්ධ දේවල්. එහෙනම් කාලය හා අවකාශය සම්බන්ධ තැන්වලදී if we need to calculate probability, then the distribution we are making use of, we identify it as Poisson probability distribution, right? So there are certain conditions in a Poisson process, so you can read it at your leisure time, right? This will not be tested. Okay. And this is the most important thing, right? This is the formula you need to keep in mind, right? How can we read this one, right? P means probability. Probability of X number of occurrences, right? Probability of X number of occurrences equals to E is a constant, E to the power minus, මම මෙන්න මෙතන පාවිච්චි කරලා තියෙන symbol එක වැරදි, yeah? Right? Here I have used Y. It should not be Y. It should be, right? It should be lambda. This symbol, right? Y එකේ අනිත් පැත්ත ගහලා. E to the power minus lambda multiplied by lambda to the power X and divided by this one. What is this? Divided by X. මෙයාට මොකක්ද කියන්නේ? X factorial. Full time students ලා දන්නවා part time කෝලිත මෙයාව දන්නව නේද? X factorial.
Yes sir.
If it is 3 factorial, what should be the answer? 3 factorial කිව්වොත් what do you mean by this? 3 factorial means what? 3 into 2 into
2
into
1,
1, right? 6. And now 4 factorial කිව්වොත් 4 into 3 into 2 into 1. 5 factorial කිව්වොත් 5 into 4 into 3 into 2 into 1. Right, that is factorial. E means what? E means a constant. You can find the value of E, and you know the value of E. What is the value of E? I think 2.718, and it goes on and on my value, right? E value, the constant. And right here we will come from the beginning. P means probability. probability of X number of occurrences. මං කිව්වේ COVID-19 patients ලා 10ක් ඉන්නවා සාමාන්‍යයෙන්. එහෙනම් COVID-19 patients දවසකට 25ක් report වෙන්න පුළුවන් probability එක. එහෙනම් number of occurrences 25 වෙන්න පුළුවන් probability එක, right? X number of occurrences. So probability of X number of occurrences equals to e to the power minus lambda into lambda to the power x. So what is this x? එහෙනම් මොකද මේ x කියලා කියන්නේ? Px means probability of X number of occurrences. If it is so, what do we mean by X? X means what? Number of occurrences, right? Varagana. Number of occurrences. Key වතාවක් වෙන එකද අපි මේ බලන්න. Number of occurrences. Occurrences. occur වෙනවා කියලා කියන්නේ හට ගැනීම, right? Occurrences. Number of occurrences. Right. What is this? This is the symbol, and this symbol we called lambda, right? Lambda. And what do you mean by lambda? මොකද්ද මේ lambda කියලා කියන්නේ? What is lambda? අපිට තේරෙන විදිහට කිව්වොත් මොකද්ද? This is what we have to identify as average, right? Lambda means the average, right? That is why always when giving examples I have used an average, right? සාමාන්‍යයෙන් patients ලා 10ක් report වෙනව නම් patients ලා 20ක් report වෙන්න තියෙන සම්භාවිතාවය. It means lambda value is 10, right? සාමාන්‍යයෙන් accidents 12ක් වෙනව නම් accidents එකක්වත් නොවි තියෙන්න පුළුවන් සම්භාවිතාවය. It means lambda value is 12, right? Average. Average, what is other term? Average කිව්වත් එකයි. තමගද? Mean කිව්වත් එකයි. Expected value කිව්වත් එකයි, right? Lambda. Lambda represents average. Right. Okay. So here, what can you say about the mean and the variance? Mean and the variance in a Poisson probability distribution. Poisson සම්භාවිතා ව්‍යාප්තියක මධ්‍යනයයි විචලතාවයයි කියන මොකක්ද කියන්න පුළුවන්? Mean and variance. Right? Mean means the average, average means the lambda, and lambda is also the variance. So in a Poisson probability distribution, mean is equal to variance. Poisson probability distribution එකක mean එකයි variance එකයි සමානයි, right? Represented by what? Lambda. ඔය lambda value එක තමයි mean එක වෙන්නේ, lambda value එකම තමයි variance එක වෙන්නේ in a Poisson probability distribution. Right. Okay, so we will discuss with this example how to find the probability in a given Poisson probability distribution. Right. Example 7. In a certain district, on an average, one house for every 500 houses has a fire during a year. There are 1,000 houses in this district. Calculate the probability that first one, exactly 5 houses will have fire during the year. Part 2, more than one house will have fire during the year. Right. මොකද්ද මේ කියන්නේ? In a certain district, on an average, one house for every 500 houses has a fire during a year. District එකක සාමාන්‍යයෙන් ගෙවල් 500කට එකක් ගිනි ගන්නවා. On an average, right? One house for every 500 houses will have fire. There are 1,000 houses in this district. ඔය කියන district එක ඇතුලේ ගෙවල් 1000ක් තියෙනවා. සාමාන්‍යයෙන් ගෙවල් 500කට එකක් ගිනි ගන්නවා කියලාත් කියනවා. And knowing those things, we have been asked to calculate the probability that exactly 5 houses will have fire during the year. ගෙවල් 500කට එකක් ගිනි ගන්නවා. දිස්ත්‍රික්ක එක ඇතුලේ ගෙවල් 1000ක් තියෙනවා. එහෙනම් හරියටම අවුරුද්දක් ඇතුළත ගෙවල් 5ක් ගිනි ගන්න පුළුවන් සම්භාවිතාවය කීයද? Right? That is what we have been asked. Right? ඒක තමයි අපෙන් අහන්නේ. Examples. Right? Examples. So how can we find the answer there? Right? Tell me what is our lambda value here? මෙන්න මේ value එක කීයද? What do you mean by lambda? Lambda means the average. Right? What is the average? On an average, how many houses will caught on fire in this particular district? මේ කියන district එකේ සාමාන්‍යයෙන් ගෙවල් කීයක් ගිනි ගනීද අවුරුද්දකට? That is lambda value. What? From these two sentences, you can get it. What?
One house.
Right. But it says one house for every 500 houses has a fire during a year. සාමාන්‍යයෙන් ගෙවල් 500කට එකක් ගිනි ගන්නවා. හැබැයි මේ district එක ඇතුලේ ගෙවල් කීයක් තියෙනවද? How many houses are there?
1000 houses.
1000 houses. It means from these 1000 houses, on an average, how many houses will caught on fire?
2 houses.
Yes.
2 houses.
Right? 2 houses. So on an average, 2 houses will caught on fire in this particular district. It means our lambda value is 2. That is how we can determine the lambda value, average. Right? Okay. So knowing the lambda value is 2, now we want to calculate the probability that exactly 5 houses will have fire during the year. Part 1. Right. Okay. Probability of how many occurrences? What is the x value we are going to consider here in part 1?
5.
Yes, 5 occurrences. How many?
5.
Right. Probability of exactly 5 houses will have fire during the year. Right? This is what we need to calculate. Right. Here, E. E means a constant, right? E is a constant. To the power minus lambda. Lambda value we have found is to be 2. E to the power minus lambda. This we need to multiply by what? Lambda to the power x. Lambda value we have found is 2 to the power x. X means number of occurrences, right? The value of x is therefore 5. And then what we need to do? Divide this by x factorial. X value is 5. It means 5 factorial. Right. That is all. So you can take directly the answer here. That should be the answer. Right. Here, how can you have this? How can you find the answer using your calculator? Right. Right. This one, me E එකකට ගහගන්නේ කොහොමද කැල්ලකේ? Right? So you have a button called alpha. Alpha button එකක් තියෙනවා කැල්ලකේ. Can you find it? Where is it? Alpha. Right? here this is alpha button, shift button එක එහා පැත්තේ, right? Alpha button, this is what you need to press. So we are going to generate the value of E. E කියන value එක එකපාර generate කරන්න බෑ. We have to make the use of alpha button, right? Alpha button is here next to shift, right? Alpha button, and then you need to press this button, base 10 log button. එයා කොහෙද තියෙන්නේ? Right? LN button, alpha, and then this one, right? Alpha and log button, then you will get the E, right? You can directly have this, right? Alpha and ln, then you will have the E on your screen, right? E, the constant. Ln, right? Alpha, don't press this plus button now, right? Then ln, then you will have E, then you want to have that power button, right? Yeah, is it power button? I will use this, right? Power button එක තියෙන තැන දන්නව නේද? This one, I'm talking about this one, right? To the power, right? To the power, this is a minus value, therefore you need to have this within brackets. Brackets ඇතුලේ දෙන්න ඕන, right? Why? Because this is a minus value. Open a bracket and then -2 and then close the bracket, right? Since it is a minus value, power is a minus value, right? To the power, open bracket, -2, close the bracket, right? Then multiplication, right? Multiplication, and then 2 to the power 5. 2, again that power button, right? 2 to the power 5. And then you need to divide it by 5 factorial, right? 5 factorial ගන්න කොහමද? 5 ගැහුවා ඊට පස්සේ then shift button, then you will have a button called x to the power -1, right? මෙන්න මෙහෙම button එකක් ඇති, x to the power -1 කියලා, right? Alpha ln button to the power, open brackets, -2 into 2 to the power 5 divide by 5 shift x to the power -1 button, right? What will be the answer? If you are getting the answer as 0.036, 0.036, it means you have done it correctly. My answer kenamad? Yes, Sureshika, 0.03608. Right? Hope others are also okay. My answer kenamad neda? 0.03608. Yes or no? This should be the final answer, right? 0.036 or 0.3608. Okay, right. That is the answer for part 1. Right, part 2. Right, part 2. What it asks? Part 2. right? Calculate the probability that more than one house will have fire during the year. More than one house will have fire during the year. It means what? More than one house. ගෙවල් එකකට වඩා වැඩි ගණනක් ගිනි ගන්න තියෙන සම්භාවිතාවයයි අහන්න. Probability of, then what should be the x value here? X greater than 1, right? එක ගෙදරකට වඩා ගිනි ගන්නත් පුළුවන්. එක ගෙදරකට වඩා ගිනි ගන්න තියෙන සම්භාවිතාවය. Probability of x being greater than 1. This is what we need to find. Right? This is what we need to find. Okay. Here, how can we find this value? This is whether this is, although this is a Poisson probability distribution, this is coming under what? This is coming under probability distribution. So a probability distributions තමයි අපි කැලි දෙකකට බෙදලා ගත්තේ. කොහමද? Discrete continuous කියලා බෙදුවා, ආයේ Poisson binomial කියලා බෙදුවා, normal කියලා එකක් ඉස්සර කතා කරනවා. Whether it is binomial, Poisson or normal, it is a probability distribution. In a probability distribution, අපි මේන එකක් දන්නේ මොනවද? Right? If I consider it like this, right? There should be a set of possible outcomes, right? There should be a set of possible outcomes. Here, possible outcomes, possible outcomes in terms of number of houses. Number of houses caught on fire. Ini ganna puluwang ගෙවල් ගන්න තමයි possible outcomes, right? Number of houses that can caught on fire, and we should have the respective probabilities. මේකනේ කතා කරේ, right? So what are the possible values here? ගෙවල් 1000ක් තියෙනවා, එක ගෙදරක්වත් ගිනි ගන්න නැතුව තියෙන්න පුළුවන්. 0 is a possible outcome. එක ගෙදරක් විතරක් ගිනි ගන්න පුළුවන්. ගෙවල් දෙකක් ගිනි ගන්න පුළුවන්. 3, 4, 5. It can goes on and on, right? ඔය විදියට up to කියන එකක් යන්න පුළුවන්ද? Right? 998, 999 නැත්නම් ඔය තියෙන ගෙවල් 1000ම ගිනි ගන්න උනත් පුළුවන්. Right? These are the possible outcomes. And in part 1, what we have calculated? Part 1 වල අපි calculate කරේ මොකද්ද? මෙන්න මෙතෙන්ට අදාළ මොන value එකද? Probability value එක. Right? හරියටම ගෙවල් 5ක් ගිනි ගන්න තියෙන සම්භාවිතාවය is 0.036. Right? So in this, what we need to find? Probability of but more than one house will caught on fire, x being greater than 1. එහෙනම් අපිට මොන ටිකද ඕන?
2.
Yes.
2, 3,
From
5.
this point onward, all these probability values මෙතන ඉඳන් එක value එකට එක outcome එකට අදාළ probabilities හැම එකේම මොකද්ද? එකතුවයි අපිට consider කරන්න ඕන. So practically it is very difficult. So what is the other method we can use therefore? අපිට මේ එකින් එකේ probability එක calculate කර එකතු කරලා ගිහිල්ලා මේක හොයන්න අපිට අවුරුද්දක් මදි. එහෙනම් අපිට තියෙන විදිය මොකද්ද? ලේසි විදිය මොකද්ද? What is the easy way? What? In a probability distribution, the sum of probabilities should be equals to here. The sum of probabilities should be equals to kiyada?
1.
Probabilities වල එකතු ඔක්කොම එකයි. Whether it is binomial, whether it is Poisson, whether it is normal, the sum of probability value should be equals to 1. If the sum is 1, if we need to find the sum of these probabilities, what we can do is from 1 we can deduct what? Probability of 0 and probability of 1, right? This is what we can do, or what we have to do, right? exam එක අනිත් විදිය කරන්න කොහොමත් අපිට අමාරු. Right. This is what we can do. Right. It means what? From 1 we need to deduct. If you consider the first one, පළවෙනි consider කරොතින් how it should be. E to the power minus lambda. Lambda value is 2. This we need to multiply by lambda to the power x. Now what is the x value? I'm going to consider this one. Then x value එක කීයද?
0.
0. Right? Divided by x factorial. It means 0 factorial. Right? This is probability of when x is equals to 0. For that we need to add probability of x being equals to 1, e to the power minus lambda into lambda to the power x. Now the x value is 1 divided by x factorial. It means 1 factorial. Right. So what should be the answer? 1 minus, when x is equals to 0, alpha ln button to the power open brackets minus 2 close the brackets multiply 2 to the power 0 divided by 0 factorial. 0.1353. Right? 0.1353. Other one, alpha ln button to the power open brackets minus 2 close the brackets into 2 to the power 1 divided by 1 factorial. 0.2706. 0.2706. Right? 2706. It means what should be the answer? I will have the final answer here, right? 1 minus 0.1353 and minus 2706. 0.5941. Is that the answer?
1.1353.
Yes, that is here, no? 0.1353. Here 0.2706. So from the total of those two, we need to deduct from 1. 0.5941. Is this the final answer? 0.5941. Okay, final answer එක මේකද?
Yes, sir. Right.
Right. Okay, clear. Poisson probability distribution වල වෙන්නේ ඔය වගේ දෙයක්, right? On an average, we will be given with a figure. On an average, මෙන්න මෙච්චර දෙයක් වෙයි. මෙන්න මෙච්චර ගාණක් තියෙනවා. එහෙනම් මෙන්න මෙච්චර දෙයක් වෙන්න මෙන්න මෙච්චර ගාණක් වෙන්න number of occurrences වෙන්න තියෙන සම්භාවිතාවය කීයද? Right. That is example 7. Right. Right. Example 8. Example 8. What it says? A telephone switchboard in a firm receives on the average 90 calls per hour. Switchboard එකකට සාමාන්‍යයෙන් පැයකට call 90ක් එනවා. Right? Receives on the average 90 calls per hour. Find the probability that during a 1 minute interval, the switchboard will receive 0 calls, 1 call, 2 calls, 3 calls, and more than 3 calls. සාමාන්‍යයෙන් switchboard එකකට පැයකට call 90ක් එනවා. එහෙනම් විනාඩියකට එක call එකක්වත් එන්නේ නැති probability එක කීයද? එක call එකක් විතරක් එන්න තියෙන probability එක කීයද? දෙකක්, තුනක්, and more than 3 calls. Right. Now tell me what is the lambda value? This is what we need to know. Related with time and space, it means we can use Poisson probability distribution. If we are supposed to use Poisson probability distribution, we should know the value of lambda. Lambda means the average. So what is the lambda value here? What should be the lambda value here?
1.5, sir.
What? Can we consider it as 90? අපිට 90ක් කියලා consider කරන්න පුළුවන්ද? Can we consider the lambda value as 90 here? Can or can't?
Can't.
Why? This is
1 hour.
yes, exactly. Right? 90 calls per hour. පැයකටයි call 90ක් එන්නේ. හැබැයි අපෙන් probabilities ආනේ with related to which time interval? During a minute. විනාඩියක් ඇතුළත තමයි මේ probabilities අහන්නේ. එහෙනම් පැයක average එක අරන් හරියන්නේ නැහැ. අපි ගන්න ඕන මොන period එක average එකද?
1
minute
minute.
එකක yes 1 minute එකක average එක. Right? 90 calls per hour means per hour how many minutes are there? පැයකටනේ call 90. පැයකට විනාඩි කීයක්
60.
තියෙනවද?
60.
You know that, right? 60. Okay. It means per minute how many calls will be there on an average?
1.5.
1.5 should be our lambda value, not 90. 90 is for a hour, per hour, right? Per minute is what we need. Why? Our probabilities are a minute එකට අදාළ. Right? Lambda value is 1.5. Now it is easy, right? Part 1. Probability of x being equals to 0. This is what we need to find. X being equals to 0. Right? It means e to the power minus lambda. Now our lambda value is 1.5. Right? Lambda value is 1.5. This we need to multiply by lambda to the power x. Lambda value is 1.5. Right? Lambda to the power x. Here the x value is 0. Divided by 0
0
factorial. X factorial will in tamai budan. X value is 0. 0 factorial. Right? What should be the answer? What should be the answer? Here this is the way. Yeah? E to the power minus 1.5 into 1.5 to the power 0 divided by 0 factorial.
4.48.
Or is it 0.2231? Can't be 4.4816. Probabilities වල range එක කීයද? හැමතිස්සෙම බිඳුවත් එකත් අතරයි වෙන්න ඕන. Right? 4.48 වෙන්න බෑ. How you got this answer, Suyama, Sureshika? Lambda value එකයි x value එකයි පටල ගන්න එපා. E to the power minus lambda. මෙතන ඉන්නේ lambda value එක. ආයි වැඩි කරන්නේ lambda to the power x and divided by x factorial. Right? Lambda ඉන්නේ මෙන්න මේ තැන් දෙකේ. X ඉන්නේ මෙතන. 0.2231. Right?
Yes, sir.
0.2231. This should be the answer. Right. So I'm not going to find, you have to find and tell me the answer for part 2, 3, and 4. Part 2, probability that during a 1 minute interval, the switchboard will receive part 2 1 call, 2 calls, 3 calls, like that. Right? Probability of x equals 1. What should be the value? Probability of x equals 1. Part 3 probability of x equals 2. Or per minute, the probability of getting 2 calls. Probability of getting exactly 2 calls per minute. That is part 3. Part 4, probability of getting exactly 3 calls per minute. හරියටම call 3ක් එන්න තියෙන සම්භාවිතාවය කීයද? Right? We need the answers here. You find and tell me. What should be the answer here? Probability of getting exactly 1 call per minute.
0.3346.
0 point what? 0.3346. 0.3346. 0.3346. Part 3. 0.25.
0.2510.
2510.
0.2510. 0.2510. Part 4. Probability of getting exactly 3 calls per minute. E to the power minus 1.5 into 1.5 to the power 3 divided by 3 factorial. Right? .1255. Hamda Sajida correct. 0.1255. Right? So these should be the answer. Right? Answer right? I hope you know how to get the values here, right? Right. And part 5. What we need to find? Probability of what? Getting more than 3 calls per minute. විනාඩියකට call 3කට වඩා වැඩි ගණනක් එන්න තියෙන සම්භාවිතාවය. More than 3 calls means what? X being greater than 3. This is what we need to find. More than 3 calls per minute. එහෙනම් හොයන්න පුළුවන් විදිය මොකද්ද? More than 3 calls කියන්නේ මොකද්ද? Calls 4ක් 5ක් 6ක් 7ක් 8ක් ඔය විදිහට දිගටම යන්න ඕන. Right? Instead of calculating isolately those values, we can do what? From 1, we can deduct what? Probability of getting 0 calls. Probability of getting 1 call. Right? Probability of getting 1 call. And probability of getting 2 calls. probability of getting 2 calls. Is that all? මේ තුන් දෙනා විතරක් අඩු කරාම ඇද්ද තව අඩු කරන්න ඕනද? This is also like this, right? This is also like this. If I consider the same here, if I consider this one here as well, right? Now the possible outcomes are not number of houses, number of calls per minute. Number of calls per minute. මේක තමයි දැන් variable එක. Right? මෙතන අපිට කලින් ගානේ වගේ නෙමෙයි ඉවර වෙන ගානකුත් අපි දන්නේ නැහැ. This goes on and on. Right? මේක දිගට ওই විදිහටම යනවා. Right? More than one call means from more than 3 calls, right? Part 5. More than 3 calls means we need to find the sum of probabilities of these values. එහෙනම් මෙතන මම මේ ස්ටෙප් එකෙන් නැවතුනාම හරියට තව මොකක් හරි දෙයක් කරන්න ඕනද?
P3 එකක් කරනවා.
Yes, P3 also I need to deduct, right? More than 3 calls කිව්වොතින් 3 කියන එක consider වෙලා නැහැ, right? You can see here 3 has not been considered. Consider වෙච්ච නැති ටික තමයි අපි separately අයින් කරලා දාන්නේ, right? 0 1 2 and 3. Right. Do we need to separately find these values again? මේවා ආයේ මේ විදිහට formula එක ලියාගෙන මෙහෙම හදන්න ඕනද?
No need.
No. Right? We have already found all these values we have found. When x equals 0, x equals 1, 2, 3, we have already found. So we can take the sum of these values directly. 0.2231 plus 0.3346 plus 0.2510 plus 0.1255. It එකතු වෙනවා 0.9342, right? 0.9342. It means what is the probability of getting more than 3 calls per minute? You know, what should be the answer? 0.0658. 0.0658 should be the final answer. Yes, 0.0658. Clear? That is how we can solve the sums under Poisson probability distributions. Right? Example 7 and 8. Right? There is something like this as well. Approximation, Poisson approximation to binomial distribution, right? Poisson approximation to binomial distribution. Poisson approximation to binomial distributions. It means though we used, right? Though we used binomial probability distribution, or if we use Poisson probability distributions, there will not be a significant difference. There are certain conditions that need to be satisfied to do so. Api Poisson probability distribution එක පාවිච්චි කළ probabilities හෙව්වත් binomial distribution එක පාවිච්චි කළ probabilities හෙව්වත් ඔය දෙකෙන්ම එන උත්තර අපිට reasonable කියලා assume කරන්න පුළුවන් වෙන අවස්ථාවක් තියෙනවා. ඒ කියන්නේ probabilities හොයන්න කිව්වට පස්සේ we can use either binomial or probability. එන්නේ ඒ විදිහට අපිට binomial උනත් Poisson උනත් පාවිච්චි කරන්න නම් two conditions need to be satisfied. Right? Probability distribution එකක් දෙනවා. Rather than determining whether it is binomial or Poisson, මේකට apply කරන්නේ binomial formula එකද නැත්නම් Poisson formula එකද කියලා we need to decide, right? There, if it satisfies two conditions, if we have used binomial or if we have used Poisson, the answers will not be significantly different. Conditions දෙකක් satisfy කරනව නම් ඔය කියන formulas දෙකෙන් ඕනම formula එකක් පාවිච්චි කරලා අපිට මොකක් කරන්න පුළුවන්ද? Probabilities calc කරන්න පුළුවන්, right? These are the two conditions. One is what? The value of n. Then n කියලා කියන්නේ මොකක්ද කියලා මතක ඇති. Can you remember what is n? First tell me how to find the probability using binomial probability distribution. Binomial probability distribution or probability කියුවේ මොකක්ද කොහොමද? Probability of r number of successors equals to what? NCR into p to the power r, right? P to the power r into q to the power n minus r. Q to the power n minus r. This is how we have find the probability in a binomial probability distribution, right? Today we have discussed what? How to find the probability in a Poisson probability distribution. Probability of x number of occurrences equals to e to the power minus lambda into lambda to the power x divided by x factorial, right? These are the two formulas we have discussed in order to calculate the probability. Now, if our distribution satisfy two conditions, right? If our distribution satisfy two conditions are there. If our distribution satisfy two conditions, either we have used this formula or if we have used this formula, the answers will not be significantly different. We are free to use any of these probability. We are free to use any of these formulas to calculate probabilities. The condition number one is that the value of n, right? Value of n should be equal or greater than, right? Equal or greater than 30. n වල value එක 30 30ට වඩා වැඩි වෙන්න ඕන. What do you mean by n? Here, what is this n? Number of trials, right? Number of trials 30ට වඩා වැඩි වෙන්න ඕන. And the condition number 2 is the value of np or the mean, right? Mean value should be less than, right? Mean value should be less than 5, right? If we satisfy these two conditions, we can use either of these formulas. මේ formula දෙකෙන් ඕනම formula එකක් calc කරලා අපිට මොකක් කරන්න පුළුවන්ද? Probability එක calc කරන්න පුළුවන්. That is what we mean as Poisson approximation to binomial distribution. මෙයා පාවිච්චි කරත් එකයි, මෙයා පාවිච්චි කරත් එකයි. There is no any significant difference. පොඩි වෙනසක් තියෙනවා. අපිට එකම උත්තරේ එන්නේ නැහැ. හැබැයි ආසන්නයෙන් යන උත්තරයක් එනවා. Right. Example number 9. Right. Example number 9. What it says? It is found that 2% of the items produced by machines are defective. Right? Machine එකකින් හදන items 100ට 2ක් defective items, දෝෂ සහිත ඒවා. A random sample of 100 items produced by this machine is investigated, right? මේ machine එකෙන් හදන 100ට 2ක් item defective items ඊට පස්සේ මොකද කරන්නේ? Random sample of 100 items produced by this machine is investigated. මේ machine එකෙන් හදන items 100ක් අපි check කරන්න යන්නේ. Knowing the fact that 2% of the items produced by this machine are defective. Right? Part 1. Find by using binomial distribution the probability of getting exactly 2 defective items in the sample. Binomial distribution එක පාවිච්චි කරලා හරියටම දෝෂ සහිත item දෙකක් තියෙන්න පුළුවන් සම්භාවිතාවය කැල් කරන්න කියනවා. Right? Probability of getting exactly 2 defective items. Right. Probability of getting exactly 2 defective items. Part 1. Probability of getting exactly 2 defective items. It means when x is equals to 2. Using binomial distribution means using the first formula, NCR. Right? So what is the n value here? මෙතන n value එක කීයද? What is the n value? Number of trials, the number of items කීයක්ද මේ අපි check කරන්න යන්නේ? How many?
100.
100. Right? N value is 100. NCR 100C R means number of successors. Successors කියන්නේ අපි defective items එන ගන්න. Defective items දෙකක් තියෙන්න පුළුවන් සම්භාවිතාවය. Therefore our R value is 2. This we need to multiply by P to the power R. Can you remember what do we mean by P? අපි P කියලා අඳුනගත්තේ මොකද්ද? Probability of success in a single trial. අපිට එන්න ඕන දේ එන්න තියෙන සම්භාවිතාවය. Defective item එකක් අපි item එකක් අහම්බෙන් ගත්තොත් ඒක defective item එකක් වෙන්න තියෙන සම්භාවිතාවය කීයද? What is the value of P? If we are supposed to take an item randomly, what is the probability of that item is being defective? What? It found that, what is the percentage? 2% of the items produced by this machine are defective. You know? 2% means what? 0.02. Right? 0.02. To the power R, R value is 2. Into, now what is the Q value? If P value is 0.02, what should be the Q value?
0.08.
Yes, 0.0898. Always P value plus Q value should be equals to 1, right? 0.98. To the power n minus r, n value is 100, r value is 2, 100 minus 2, it means 98. Right? So what is the probability here? කැලේ මතකයි නේද? 100 shift division එක 2 into 0.02 to the power 2 into 0.98 to the power 98. 0.2734. Yes, 0.2734. 0.2734. defective items හරියටම දෙකක් තියෙන්න පුළුවන් සාමාන්‍ය 127ක විතර සම්භාවිතාවයක් තියෙනවා. Right? That is part 1. 0.2734. Right. Then part 2. මොකද කියන්නේ? check for suitability of the Poisson approximation. අපි මෙයාව කැල්කරේ binomial probability distribution එකේ formula එක පාවිච්චි කරලා අපිට කියනවා මොකද්ද? check for suitability of the Poisson approximation. මේකම අපිට Poisson එකේ මෙන්න මේ formula එකත් පාවිච්චි කරලා කැල් කරන්න පුළුවන් මට්ටමක තියෙනවද කියලා check කරන්නලු. suitability එක check කරන්නලු. So how can we check the suitability? මෙයාව binomial distribution එකෙන් හැදුවා වගේ Poisson එකට අදාළ probability එක හොයන formula එකත් පාවිච්චි කරලා හදන්න පුළුවන්ද බැරිද කියලා how can we decide? Based on these two conditions. මෙන්න මේ conditions දෙක satisfy කරනවද නැද්ද කියන එක අපිට බලන්න වෙනවා. satisfy කරන්නේ නැත්නම් we can't use Poisson distribution, right? මේ condition දෙක satisfy වෙනවද? Condition number 1, value
Satisfy.
of n should be equal or greater than 30. Is it? n value එක 30ට වඩා වැඩිද? Yes, it is greater than 30. It is 100. So condition number 1 is satisfied. Right? Condition number 1 is satisfied. Then second one, mean value should be less than 5. What is the mean value here? Mean value එක කීයද? Mean value එක කීයද? Mean value එක කොහොමද හොයන්නේ? How can we find the mean value? Mean value right here. Can you remember this?
Average.
Mean value. How? N into P. Right? Mean and standard deviation of a binomial probability distribution. So this is a binomial distribution. So we can find the mean by using the formula N into P. Right. Then here N into P kiyak kenawada? The value of N is 100. 100 need to be multiplied by P. P means probability of success. May be P value. Right? This is P value. This is N value. And N into P we will get the mean. 100 into 0.02. What is the answer?
2.
2. 2 is less than 5. So it satisfies the second criteria as well. Or the second condition as well. Right? So both the conditions have been satisfied. ඔය කියන conditions දෙකම satisfy කරලා තියෙන්නේ. එහෙනම් අපි මේ formula එක පාවිච්චි කරන්නත් පුළුවන්. මේ formula එක පාවිච්චි කරලා probabilities හොයන්නත් පුළුවන්. Right. So we have checked the suitability. It is suitable to use both the probability formulas, and by using Poisson approximation, find the probability of getting two defective items. Right. එහෙනම් අපිට කියනවා suitable ද කියලා බලන්න. Suitable conditions දෙක satisfy කරා. එහෙනම් Poisson approximation එක පාවිච්චි කරලා part A, the probability of getting two defective items. Right? Part A වල අපිට කියනවා defective items දෙකක් තියෙන්න පුළුවන් සම්භාවිතාවය. X equals to 2 using Poisson approximation. කලින් හෙව්වෙත් ඒකම තමයි. By using what formula? මෙන්න මේ formula එක පාවිච්චි කරලා තමයි අපි කලින් හෙව්වේ. Right? And then we got the answer 0.2734. Now we have asked to calculate the same using this one. මේ formula එක පාවිච්චි කරලා හොයන්න කියලා කියන්නේ. E to the power minus lambda. Then lambda value එක කීයද?
2.
What is lambda value? Lambda means what? Lambda means the average. Average. Yes, average means the mean. Average කියලා කියන්නේ mean එකට. Right? Average means the mean. Mean එක කරන්නේ කොහමද? In this sort of, in a binomial distribution, we can calculate mean by the formula n into p. Right? So the value of n was 100. The value of n is 100. this we need to multiply by value of P. The value of P is 0.02. Probability of success in a single trial. It means our lambda value should be 2. Right. So e to the power minus 2 into lambda to the power x. X value is 2 divided by x factorial. It means 2 factorial. So what is the answer we will get here? එකම දේ අපි formulas දෙකෙන් හොයනවා. X equals to 2 using binomial probability formula. X equals to using Poisson probability formula. So what is the answer here? 0.2706. 0.2706. Right. Yes. Right. So see here, when we have used this one, the answer was 0.2734. In part A, in second part, the answer we got was 0.2706. හරියටම තිතටම සමාන වෙන්නේ නැහැ. හැබැයි මොකද්ද? එක ළඟින් යනවා. Significant differences නැහැ. ලොකු වෙනස්කම් නැහැ. It is almost around 27%, right? The probability. Clear? That is what we call Poisson approximation, right? If we, so it gives us the option to use either of these formulas if it satisfies these two conditions, right? ඔය කියන conditions දෙක satisfy කරනවා නම් මේ formulas දෙකෙන් ඕනම formula එකක් පාවිච්චි කරන්න පුළුවන්, right? So these things you can find, right? Less than 2 defective items. Less than 2 defective items කිව්වොත් කොහමද? Less than 2 defective items. Probability of x being මොකක්ද? Probability of x being less than 2. This is what we need to find. මෙයා හොයන්න පුළුවන් කොහමද? Probability of x being less than 2. එහෙනම් මොනවද අපේ එන possible outcomes?
1 minus 1 minus 2 plus 0.
What are the possible outcomes? No. 1 minus 1. අපේ possible outcomes මොන values වලට අදාළ probabilities වල එකතුවද මේ අහන්නේ? Probability of x being less than 2. එහෙනම් මොනවද? 0 is there, 1 is there. 2 can we consider?
1 is there.
Right? So what we need to have is the sum of these two. Probability of 0 defective items plus probability of having exactly 1 defective item. Right? This is what we need to find. Less than 2 කියලා කියන්නේ එක්කෝ එක එකක් වෙන්න ඕන නැත්නම් 0 වෙන්න ඕන. එහෙනම් මේ දෙකේ probabilities වල එකතුව should be the answer. Right? For part B. For part C, at least 2 defective items in the sample. At least 2 defective items in the sample කිව්වොත් මොකද්ද? Probability of x being what? At least 2 defective items කිව්වොත් what are the possible outcomes? At least 2 defective items.
2, 3, sorry. 0.2.
At least 2 defective items. අඩුම තරමේ item දෙකක් වත් defective item වෙන්න පුළුවන් සම්භාවිතාවය කිව්වොත් the possible outcomes are what? 2, 3, 4, 5, 6, 7, 8 ඔය වගේ කීයට යනකන්ද? Up to 100. Right? It means x being මම මෙහෙම ලියුවොත් හරියද? Is this correct? Is this what we have been asked for? මේක හොයන්න කියලාද කියන්නේ?
No.
right? P probability of x being greater than 2 the x being equal or greater than 2 the at least කිව්වොතින්
equal
අඩුම තරමේ දෙකක්වත් කිව්වොතින් the value 2 is also we need to consider. It means the probability of x being equal or greater than 2, right? Equal or greater than 2. එහෙනම් මෙයා හොයන්න පුළුවන් කොහොමද? 2 3 4 5 6 7 ඔය වගේ up to 100 කැල් කරලා ඒ ටික එකතු කරන්නත් පුළුවන්. එහෙම නැත්නම් ලීසි විදිය මොකද්ද? From 1 we can deduct probability of what values? Probability of 0 defective items and probability of getting 1 defective item. Can I consider 2 here? P2? Can no can't? Can't, right? දෙකට වඩා at least 2 defective items කිව්වොතින් 0 and 1 විතරයි එන්නේ නැත්නම් ඊටු ටික ඔක්කොම මේකට එනවා, right? Okay, so hope you can find these answers. May part A, B, C වලට answers හොයන්න ඕනේ using this one, using Poisson probability formula, right? Okay, clear, right? So what we have left to discuss is on normal distributions, right? So normal distributions we will discuss with a separate lecture, right? Normal distributions කතා කරන්න තියෙන්නේ අපි මේක වෙනම session එකකින් කතා කරමු and I will join the IT students as well, right? For IT students also they need to discuss this chapter, normal distributions. So apart from full-time, part-time, BA ළමයි, so I will add the IT students as well, right? So you can meet new friends. Okay, so shall we stop?
Okay, sir.
Right? Okay, thank you.
Okay, sir. Thank you.
Thank you.